So you're probably saying to yourself, what's going on? Why are we in chapter 3? There is a section in chapter 3 that involves limits. And it doesn't seem to make any sense why the authors waited until chapter 3 to talk about limits, when in fact we should talk about limits when we're covering limits. Today's lesson is pretty much a pre-calc review. Good. If you like pre-calc, this will be easy peasy. I'm also going to give you a number of tools to help you solve these problems. You can use whichever one you want, for the most part. So hopefully, of these 3 techniques, one of them will click for you and allow you to solve these problems. So yesterday, we did the behavior of a function around an asymptote. So we were looking at the value of the limits going up to infinity or down to negative infinity. Today we're going to tweak it a little bit, and instead of looking at the y values going up to infinity and down to infinity, we're going to look at the x values going out to infinity and out to negative infinity. Okay, so we got that, and then horizontal asymptotes. You'll have to refresh my memory on how you find horizontal asymptotes. I'm a little shaky on it. And we'll talk about the infinite limits as you approach infinity, and of course you should be able to converse in Pig Latin. SCA?
Yeah.
One? SCA? What? Yeah, not Italian, Pig Latin. Okay, so I've got a function that has a horizontal asymptote at 3. In that little chunk of that picture, which goes from about 2.5 or 3 to negative 3, you see what that function is going to do. And as I zoom out on that value is going to get closer and closer and closer to 3. One of the big differences between a horizontal asymptote and a vertical asymptote is sometimes it can cross a horizontal asymptote. Doesn't happen very often, but occasionally it will. So if I go very far to the right, what's going to happen to the value of the function? What does that mean? What's it going to get? What's the y value going to get very close to?
3.
3. Are we all good on that?
Yes.
If I go to negative infinity, the value of the function is going to approach 3. Okay, so visually we're good to go, right? So if I give you a picture and ask you the same question, that should work out okay, right? Because that's the idea of an asymptote. What does an asymptote mean? It means it's a line that the function gets very close to, but theoretically doesn't ever really equal, even though I talked about the contradiction with horizontal asymptote. All right, so that's method number 1, looking at a graph, which it seems that all of you have that under control. There's some new notation for you. The limit of f of x as x approaches infinity, and the limit of f of x as x approaches negative infinity. Go very far to the right, very far to the left. And they approach the value of 3, like we said. Okay, so how are we going to do that if, let's suppose we don't have a picture. Let's suppose we just have a function. Or, yeah, let's just say a function. Let's say, for instance, it shows up on the non-calculator portion of the exam. How are you going to handle that? Well, you could try to plot it, but that might be a train wreck based on some of these functions, so I'm going to show you a couple different ways to do it. Oh, you know what? Let me ask you before I show you that. How do you find a horizontal asymptote?
Something that
When x is 0,
Shh. Go ahead. Not you, shh, them shh.
Okay, if it was like a 3 asymptote, let me correct me if I'm wrong. If it was like 3x at the top and x at the bottom, then the x is cancel, it's just 3. Or like, if they're the same, if it's like x and x, then the asymptote's like 1 or is it 0? I think it's 1. Or it doesn't mean it. Never mind.
So what you're saying is, if the degree of the numerator
Yes, the degree of the numerator
matches the degree of the denominator, then the asymptote is where?
Or does it make sense? Wait, 1.
I'm sorry, hold on. Okay, this is important. I never learned this, and people come into this class knowing that rhyme. I think Davis taught that, right? So what is the rhyme? Can somebody fire? Okay, that's part of it. That's one of the three.
And then top just stop. Is that means like there's no it's I don't know what
Big on top, just stop if the
bottom is
If the bottom is heavy, the line is
steady at y equals 0. Okay, and the third scenario?
There wasn't a third one.
Well, there is a third one. That's what Nina was talking about. Okay,
And
say
then
again.
what was the first one you said? The top?
If the top,
Big on top is
if big on top.
But isn't there a rhyme?
At
So
what?
that's you don't know the rhyme.
No, after.
Okay,
I don't
good.
think so, no.
All right, so we got all three. You probably didn't hear any of that, but I'll go through it. Okay. So there's scenario number 1. If the top is heavy, no, if the bottom is heavy, then the line is steady at y equals 0. Okay. So in other words, if the degree of the numerator is less than the degree of the denominator, it's going to be the x-axis, also known as y equals 0. The biggest thing to get out of what we're going to do in the next couple of minutes is, if you can find the horizontal asymptote, you can find the limit as it approaches infinity. Does that statement make sense? If you can find the horizontal asymptote, that will allow you to find the limit as x approaches infinity or negative infinity, because if you go very far away, it's going to get closer and closer to that horizontal asymptote. Okay. Scenario number 2. Was there a rhyme for this one? If they're the same? Okay. So if the degree of the numerator equals the degree of the denominator, then you take the ratio of the leading coefficients. Degree 2 on the top, degree 2 on the bottom, the leading coefficients are 3/2, therefore the asymptote is at 3/2. And then the last scenario, am I going too fast or are we good? We're good? Good. All right. The last scenario is the one we talked about, the one that you set to stop, but we didn't stop. If the degree of the numerator is greater than the degree of the denominator, then you get an oblique asymptote. It is not horizontal. Technically, it's not a horizontal asymptote, but we're going to consider it part of the horizontal asymptotes. It will slant upwards or downwards. You are not going to have to find the equation of that oblique asymptote. All you're going to need to be able to do is find the slope. Not even the slope. You're going to have to find out whether the slope is positive or negative, and I'll show you what that means in a second. Because you'll recall, probably in pre-calc you did a little long division there. You took x cubed and divided it by 2x squared minus 1, and it was a painful experience. Yeah, this will not be as painful. Okay? So those are 3 scenarios. So this is your second tool to use. The first one was looking at the picture. The second one is finding the horizontal asymptote. The horizontal asymptote. The horizontal asymptote. I will try to enunciate more carefully. And if you can find that horizontal or oblique asymptote, you should be able to find the limit, because they are equivalent. Which is exactly what that says. If you know the horizontal asymptote, then the value of the limit is going to be the value of the horizontal asymptote. The rules change a little bit when it's oblique, and we'll cover that in a second. Okay. All right, so let's talk about this puppy. That doesn't really fit into anything we've done already. That's not a rational function, is it not? Can I make that into a rational function? In other words, can I make that one fraction? Yes, do it please. Find a common denominator, write it as one rational function.
It's 90 degrees really wide open.
Is it? But it doesn't feel like the air's on.
It's gonna hold it.
Whatever, we'll be fine. All right. Andy, what do you got?
5x squared minus 2 over x squared.
How do you do? Good. All right. What's the degree of the numerator, Andy?
2.
What's the degree of the denominator?
2.
Therefore, where's the horizontal asymptote?
Y.
5.
5.
Y equals 5. So therefore, what's the answer to the limit problem? 5. Done.
We can only do this if it's infinity. So like with the other ones, we still would have to plug in the number.
Any problems? Okay. Good. Let's look at a different way. So we know the answer should be 5 regardless of what technique we use. So you could take out your graphing calculators and graph 5 minus the quantity 2 divided by x squared, but we've done that already, so let's move on and try something different. I could have done this. Could have split it into a difference, because the difference of a limit, no, the limit of a difference is the difference of a limit. That would have worked. But that's still just what we did, algebraically manipulated. Where did 0 come from?
You divide 2 by a really, really, really big number and it becomes 0.
Perfectly said. I don't even want to comment. I just want to make sure everybody heard that. Yes? Awesome. Requires no further discussion. We're going to use that idea a lot in the last technique I have for you. So if you didn't follow or hear what she said, raise your hand and we'll go over it again, or you're going to be completely lost. Could you go through it again?
So, like, when you divide 2 by a really, 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 really big number, like infinity, it gets really small, so it's basically just 0, so we just kind of call it 0.
So think of it like 2 over 1, 2 over 10, 2 over 100, 2 over 1,000,000. The fraction keeps getting tinier and tinier, which will eventually, if it gets big enough, like infinity, that fraction will just go to 0. Okay? Any problems with that? Beautiful. Okay. So we did that technique. Andy helped us with that. We found the common denominator, looked at the leading coefficients there to get 5, and we got the same answer that we already expected. Now, let's change it a new technique for this one. First of all, what's the answer? 2. Good. Any problems? Degree of the numerator is 1, degree of the denominator is 1, leading coefficient 2 over 1, therefore our answer should be 2. Great, so we know where we're working towards, but I want to show you the other technique. Okay, so the other technique is to divide everything by the largest power of x. Okay, and in this case it's just plain old x. But if my highest degree is an x squared, I would divide everything by x squared. And I'll show you why in a second. By dividing everything by x, it's going to make this really ugly. But if you do a little bit of work, it's going to simplify. So, highest degree is x. Therefore, divide everything by x. That turns into this. Why do I want that? What's the limit of 1 over x as x goes to infinity? 0. So anything with an x in the denominator is going to just disappear. It's going to go to 0. So the limit of 2 is 2. The limit of 1 over x is 0. The limit of 1 is 1. The limit of 1 over x is 0. They all disappear, and we get the exact answer we were expecting, which is 2. Realistically speaking, this is not a great technique. It's mathematically sound, However, you wouldn't go through all the hassles, because when I go back to this page, and I just gave you that, everybody fired out the answer of 2 right away. However, as the problems get more complicated, you might find this technique usable. And again, my job is to give you as many tools as possible to help you solve these problems. So now you have 3. Graph it and look at the picture. Find the horizontal asymptote, or do this whole dividing out technique thing. By the way, have I used this term before? Okay, indeterminate form, 0 over 0, infinity over infinity. When they pop up, those are bad. Technical term for those is indeterminate form. Okay, so and there's a picture, which is exactly what we expected. It's going to get very close to 2. Okay, but again, you're just going to do that.
Will there be a difference if it's going towards negative infinity, or would it just be 2? So?
Great question. In this problem, would there be a difference?
No.
No. It is possible, however, that you could deal with a problem where you would get different answers, which we're going to explore in about 2 seconds.
Great.
Okay. 3 different techniques. Okay, let's start with graphing. Get out your calculators or your iPads, graph that puppy, tell me what the answer is. You know what the answer is, but do it anyways. Very, very big on a fraction. You get to the fraction, it's very, very small. So think about this, 1/2, 1,000, 1. Okay, so you're going to have a vertical asymptote there, I think. Yeah, somewhere, some weird value, who cares? But we're looking at the horizontal asymptote there. Okay, so 1 is looking at the graph, which you're doing now. 2, what's the degree of the numerator? 2, what's the degree of the denominator? Where's the horizontal asymptote? 3/4. Got your answer. Last technique. What are you going to divide everything by? X squared. Okay, so here's technique number 1. Dividing everything by x squared. You get that mess on the left. 3 minus the quantity 3 divided by x plus the quantity 2 divided by x squared. Over 4 minus 7 divided by x squared. All of those last 3 terms are going to disappear and go to 0, which leaves you with 3/4, which is exactly what we were looking for. We knew that already. Again, not the most practical technique. I'm just giving you weapons to use. What is this? Is it okay? Is it? Oh, 1. Horizontal asymptote we talked about already, right? Okay, beautiful. Graphing it. Should have gotten something like that. Your calculator might not draw in the asymptote. So you got to kind of ballpark it. Now notice the graph there. What's happening over on the right? It's crossing that horizontal asymptote. Remember, that's okay. Because it's going to bounce below it, but then it's going to start to level out and still stay close to that 3/4. Never crosses vertical asymptotes. 3 different techniques. What happens if there's no horizontal asymptote? So this does 2 things for us. Number 1, once we get done with this discussion, I'm then going to show you how to handle an oblique asymptote. But what happens, in fact, just to be sure you're on the same page, graph x cubed and take a look at it, please. You should all know what x cubed looks like, but what happens when you go very far to the right on x cubed? What's the y value go to? Infinity, correct. What happens if you go very far to the left on x cubed? Negative infinity, correct. So it is possible to get a non-numerical answer, or infinity or negative infinity as an answer from a problem. Okay. That's not a rational function. There is no horizontal asymptote. You got to figure out a different way to get it. that's what the picture looks like, so you can see. And that's kind of, hopefully you recognize that's kind of common sense, right? What's infinity cubed? Infinity. What's negative infinity cubed? Negative infinity, because a negative number cubed is still negative. What if it was x squared instead? Infinity and infinity, right, because they both go up. Even functions go up or both down. Odd functions do the whole starting activity. Okay. Let's go back to this puppy. Where is it? Nope. That guy. Okay? And let's talk about how to find the limit. Whoops. The limit of g of x as x goes to infinity for this particular function. So a little flashback to pre-calc. In pre-calc, finding the oblique asymptote, you would long divide the numerator by the denominator, get an equation. That equation would be a linear function. That would be the line that constitutes your oblique asymptote. We don't care about the line. We care about only one thing. Does it have a positive slope or does it have a negative slope? And the answer comes about from looking at the sign of this and this. So back in pre-calc, you would have done this. You're seeing that, right?
Yeah.
Why won't it let me? That was weird. And that 2 looks like an R. Okay, so you do that. And the first step is how many times does 2x squared go into x cubed, and you get some value and bring it down, do the whole division thing. We don't care. All we care about is this thing. Is it positive or negative? Positive, because it's a positive function or value divided by a positive value. That's a positive function. Which means the slope of your oblique asymptote would be positive. It's going to go like this, like it does here. So if I just give you that line and I tell you to go out to infinity, what's the y value going to do? Infinity. It goes up to infinity. If you go to negative infinity with that line, where's the y value go? Negative infinity. Good. What if the slope is the other way? It switches, right. If I go very far to the left, it goes very high upward. If I go very far to the right, it goes very high down or very low downward. Okay, so we don't care about, right now we don't care about the picture. We just care about the value of the function. So in this case, I go very far to the right, I get infinity. I do the limit as x approaches negative infinity of g of x. We get negative infinity. Okay, so oblique asymptotes shouldn't matter. Okay, doke. I think we're good to go. Got all this other stuff done. We went through all that. Now, do we have the dating slide there?
Yep.
And okay, we're all good.